We'll start our lecture. So today I will try. So today we will finish the camera model and start to talk about camera calibration. For the camera calibration, important one is I want to teach you two parts. One is the optimization process. The second is the AR, augmented reality. Here, last week, we mentioned about on page 83. Page 83, we mentioned about homogeneous, especially vector matrix. Okay, and the unit vector equal to unit vector times amplitude. Based on this one, we also mentioned a little bit about singular value decomposition, SVD. Because SVD, they can factorize or decompose, so 因式分解 any matrix to three parts. Okay, so it's a eigenvector, eigenvalue, and rotation matrix. After that one, we talk about how, based on the homogeneous matrix, how can we solve the unknown parameters? And we use we call optimization process. So basically, there's a closed form solution. We have a pseudo inverse. And on pseudo inverse, okay, so after we try to solve this kind of problems is a sum square difference, summation square difference, sum square difference. And in deep learning, we have an average of batch size 这批次每次有几个就这样讲1000个 data 每次100个一组这样子，这一个 batch 一个100这样子。And we also, so right now for the deep learning, they use this one or cross entropy. But recent 2 years for the loss function, people come to Lagrange. That's meaning we have some constraint. And I originally have this page, but last night I added one more page, and you can download from the FTP site. I include this one. Okay, so for Lagrange, is this function. So original, okay, we use sum square difference or mean square difference. So this is a ground truth. This is the estimation result. And W is the parameters of weight. That's the parameter of deep learning. You sum up together. So this is the estimation result. This ground truth. We try to minimize those functions. So this, and if we use the mean squared difference, they have an average divided by n, the entire one. And right now, more paper include one more term. We call constraint term. And this one, entire one, is Lagrange. And this kind of idea in a supportive vector machine, as a previous page 85. Supportive vector machine, they also use, this is the original sum square difference. And they have one more constraint here. So they will become this one. So this is the original one. There's a constraint. So they become Lagrange. And you try to minimize the unknown parameters using gradient descent method. So suppose so right now you don't know W, you don't know B, you don't know the multiplier of Lagrange. 这个 alpha 你不知道，所以你不知道 WB 跟 alpha So what you will do, the same as gradient descent method, you just derive to the W, derive to the B and alpha， 就是你微分，对这三项分别做微分，是这样子。那我把因为这个式子 ，this one probably is from SVM. SVM is a good method. Why is a good method? Because they have this kind of equation. SVM is very good, but it's a machine learning. Okay, and they have this equation. SVM 是用这个 equation.
没有错啦。事实上，美国现在在编预算嘛，在编明年的预算啊。我估计在这个月跟下个月，你会陆续看到很多说美国已经打不过中国的报告了。我们最近也看到很多这样的现任将领，对不对？在讲说
现任
6年内就要发生武统了啦，或者是说哎。
Whatever. Okay. Any questions about that? Okay. So this is machine learning. We move the method in machine learning to the deep learning. So deep learning is the mean square difference, but it's some square difference. But right now they have this kind of constraint. So 越来越多的 deep learning 已经加上这个 constraint term 了，让结果更好。那这个整个 how can I explain this one? So this term actually in physical meaning is that try to reduce the bias. 你做最佳化 you try to estimate the parameters W. Okay, and your result is what's the bias? Bias is this one. See, you hit the target. Target is in the center. Target, and bias is meaning you hit, but it's a little bit away from the center. So this is a bias. 它偏移了，有没有？偏移了。So when you collect more data, you optimize this one, and your purpose is you hope all the samples and the answer can be more close to the target. That's this term. But this term has one problem. If it's diverse, and the error or the variance, like the Gaussian distribution, right? You hit this one, so your mean. So this is the mean value from this one. You close to the average value, mean value, and that's good. But mean value sometimes bias, has larger bias. That's not good. Okay. And the other thing is so how do you improve this one? Two methods. One is collect more data. If you collect more data, your answer will be here, not here. So try to improve the deep learning. One method is collect more data. The second method is you try to improve your optimization method. Try to improve your optimization method. That's meaning you need to adjust your gradient descent parameters. The second method because you use gradient descent method, but the parameter is not adjust well. So we need to try to adjust the parameters of gradient descent. The two methods. So try to improve this one. But later I will tell you the EM method, the new EM method to improve instead of gradient descent. I'll talk about one later. So this one. And for this term, why we need to have a more constraint term, one more constraint term, is try to reduce the variance. This term is more constraint. More constraint is not the result. We don't want the result diverse. 我们不希望结果发散出去。那这个就是发散，这个就是发散。The variance, you have a large variance. That's not good. So if you include one more constraint term, your variance will reduce. the Gaussian distribution, the variance of Gaussian distribution will reduce, will be concentrated either here or either here. So in this one, actually, which one is good? Actually, this is not good. Variance, bigger variance is not good. This one is not good. This one is not good. Because it did not concentrate. But this is the perfect. But this one you have a bias. But this is fine because even though you got a result, you know the bias is like a 10 unit. So you know your result have a 10 unit bias. You just reduce the 10 units will be the center. 就是你这个就发散不好，你虽然没有达到，对不对？就像你打靶一样，你在打靶，你打这个就是散弹嘛。散弹那是打会打死人，那很好。但是我是说，如果击中是希望击中，不要伤到无辜的话，那这两个都好。那这个你虽然是偏差，所以那个狙击手他要去测那个风向什么，所以他瞄准的时候不会瞄准。假设我要瞄准你头部，因为那些风的东西，他瞄准不能瞄准头部，他会每支枪的性能不一样，所以他可能瞄准旁边一点点，打到才会打到头部。因为你知道这支枪的性能这样子，所以跟这个一样。你知道它你知道它这支枪的 bias 是多少，那你只要把那个调回来，这样就集中就 hit 到这样子，所以这个有希望，这个希望就比较不大这样子。So that's meaning the constraint is better. Okay, so that's what I try to tell you. So that's for the camera model. 这个才慢慢在发生哦，这一年才没有很多 paper， 但慢慢有这个趋势啊。所以你如果读最新的 paper， 你会发现新的 deep learning paper 开始 deep learning paper there's some papers start to have this kind of constraint. We go for next lecture about camera calibration. And camera calibration, basically I use this paper. It's a technical report. So I will follow this technical report because it's better than the paper. So we'll use this one. So you can study this one, this paper. Almost the same because my lecture is based on this one. So from this camera calibration lecture, what will I teach you? So before we talk about intrinsic parameters, extrinsic parameters of camera model, this one. So right now we try to solve the unknown parameters. So I use this lecture to teach you. The purpose try to teach you how do you apply optimization process or optimization method to solve our unknown parameters. Okay, that's the purpose for this lecture. So we try to use, so based on this, any kind of parameters, we need to transfer to be in homogeneous matrix format, AX equal to B. And then we try to solve either A or X using optimization method. But in computer vision, machine learning, or deep learning, they don't have many methods to solve the unknown parameters. So I will teach you. 就是我会教你的方法，就大概这些方法会用到。 所以没那么难，就只有这几个方法而已。Okay. So that is why we need to do the camera calibration. Why? So first of all, I tell you what's the camera calibration. So last time we already mentioned a little bit about camera calibration. So you have a chessboard, right? So this is the chess. So this is a chessboard. I 这样的。Oh, yes, yeah. Oh, good. Okay, you know. Oh, I stop at this one. Okay, so any board, this is a chessboard. Okay, and on the website you can print out this chessboard and attach on any board. Attach here. So this chessboard, and for example, for this one, for the size of the square, 2 centimeter. So this you know this, you should know this one. So this is a 3D object. This is a 3D object. And for the size of each square is 2 centimeter by 2 centimeter. Okay, so you print out this one. So this is a chessboard. Okay. And so based on the chessboard, right, front of camera, any camera you can calibrate is the focal length, principal point. So you can do this kind of move this one. And move, you should move the motion, should be larger. Larger is better. Don't move just like this one. It's not good. You should move bigger angle. Okay? Don't move small angle. That's not good. Because it's the interpolation. If you move like this one, you move larger as 45 degree, 45 degree. That's meaning the 45, 30, 0, 30, the other one, the other side, 30, 45. That's meaning you can do the interpolation within plus minus 45. If you only move 10 degree, that's meaning if your object, the angle of object for the rotation is more than 10 degree, and you will fail. 就是你在移动的时候角度要大一点，因为它是一个内插的动作啊，你不要只移小的这样子啊，那些角度变化这样。Back to here. So like this one, and you also rotate. We say again. So after you take the photo here and OpenCV already write the source code for you. So you call the function. So for each corner, the first corner is here, not outside here. No, the first corner is here, inside here. Why? Because they say, because here, sometimes they do detection tracking will fail. So they feel this is the corner easy to process. Show again. So this picture I will teach you is exactly the same. So, and I think our homework will include this one. So everybody should learn how to calibrate the camera, any kind of camera. Okay. So when you calibrate this one, what do I mean? Calibration is meaning you try to find intrinsic parameters, extrinsic parameters. So after you find the intrinsic parameters and extrinsic parameters, you will find this is camera location. 你在任何摄影机前面，你只要把一块板子这样子，然后校正完了以后，就知道摄影机位置在哪里。神奇。 所以你就知道摄影机位置可以校正出来，就 camera model。So after you find the camera model, also you can find the object position here. So you can do the 3D reconstruction, also do the simulation of the entire, we say is a scene, 这场景，这 scene 这整个场景，你就可以把它恢复回来。我再讲一遍，你用这个校正板，只要任何摄影机摆着，你把它装校正完以后，大概15到20个角度，内部参数、外部参数就会找到。这时候呢，你的摄影机的在这个世界坐标里面，摄影机的位置，然后这物体的位置，你就可以像右边这样把它模拟出来。So this is a 3D concept from 2D. So when you take an image, take a photo, right? Right now your cell phone, when you take a photo, they will ask you sometimes what's based on GPS. Where is your location when you take the photo? Why they want to do that? Why they want to do that? There's one application here. I tell you. This one application. This is in the internet website. The people, I stop here. So anyone, I don't know you, but please put your photo and anywhere anybody try to take the photo about this one. 那个罗马竞技场放上去。那我是工程师嘛，然后你就这样拍那么多张。And based on the photo you take, I can reconstruct the entire with a Roma something theater something like that. 可以把这个整个重建回来啊。我们看一下它这个动作。So they collect many photos. Some is a zoom in, some is a zoom out. Difference, right? So details. And you have a GPS, so we know your position. But the GPS, that doesn't mean, the GPS is the other reference. But from here, any photo, they can estimate your 3D position. And it starts to reconstruct because each image is like this one, like a chessboard. Each image is like use chessboard. And then do the stitching. So you can reconstruct to 3D, and this a point cloud. 点云图就出来了，然后 texture 再放上去，这个整个建筑物就恢复回来了。这目前的技术可以做到这个程度。So why Google hope you can put an image there, or Facebook you can put an image there, because there's one purpose. So Google Map they can reconstruct some of 3D buildings or 3D models or 3D objects， 它可以把它汇入嘛，所以现在街景已经开始有 3D 的东西出现了，那你就可以去各种角度去看它，去转它这样子。这从天空看嘛，整个。So this will relative to the camera calibration. And the other useful one is the AR. So in your homework, I will teach you the AR. Okay. me check it. This one. So we'll teach you something like this one. Sorry. Chessboard. This graphics, just 图学的东西 3D model. So you can do this one. But I won't teach you exactly this one. I just teach you some. We will put something on the board. 我会教你只是放在 board 上面有个虚拟的东西啦。因为这个还要这个，我可能会做不完。但可以做类似这样子哈。我会教你这个。那这属于图学的东西哈，把影子，这是 graphic 就可以做得出来。So I like AR. So I say that in your cell phone, there are more apps about AR. Okay. So right now in your the technology can easy to process this one. 那我要教你这些动作哈，这种虚实整合嘛哈，这 AR 东西。好，那这门课目的是要教你会做。那记得哈 ，any AR, the important thing is you need to have a plane, a ground. You need to find a ground for the object. This AR, the major purpose, you need to find a ground for him. So right now, how to find a ground? Many AR app use manually. They ask you, can you manually select the ground position for him? 因为你要找 ground 不容易，所以现在很多 AR 的 APP 是叫你用人工方式先选择，它才知道物体要放在哪里，这样子。OK， 所以不是100%那个全部自动的。那这个也是，这个你比较喜欢玩的啊，这是 AR 东西。对，就可以打来打去。Okay, so this is the AR 东西。有人说 AR 比较好玩啊 ，AR 比较好玩。Okay. 好，教你最后还有一个忘记了，还有一个刚刚要给你看是这个 AR 东西，这个不错。So I want to let you know that each time when I teach a lecture, I want to let you know what's the application of technology.
World in a whole new way.
They'll explain. So when you take your cell phone outside and take anything, they'll explain to you.
Allows the user to see the world in a whole new way.
Be able to recognize things and see things and immediately get information from using your smartphone.
This is a hotel price.
Imagine the ability to browse life like we browse the web.
It might seem revolutionary, but the technology started in 1962 when cinematographer Martin Healy created the sensor in Fidelity's first real
So in the
world
United States,
application
many technologies from the military, 他们是从军方的技术慢慢转移到民间，是美国
projected
的，是这
onto
样
a
做。
transparent glass screen, which takes away the distraction of looking at gauges.
可是 AR 是从军方这种飞机这种过来的，
Heads-up displays are now starting to appear in cars.
这是抬头显示
One of
幕
the
嘛，
pioneers.
这慢慢很普遍的。
displays all the information such as speed, navigation. It projects
So you drive a car, you don't need to, roll down your head, just see straight, and they'll explain to you and
These activities such as travel and shopping
give the price.
can be applied to medicine and education. With the technology's rapid development, its potential.
So this market will be huge, and we just start. So AR just starts, and the application is huge.
Many brands have adopted this new marketing strategy, including IKEA.
So cell phone is very important. Cell phone is very important, and then 5G or 6G because into something you search from the internet.
animated 3D furniture instead of
This
seeing a
IKEA
video, you actually
IKEA's
look at the
IKEA's
visual
things.
on your camera in the app, and it visualizes the bed.
It's your home.
Augmented reality is also used to replace manuals and show real-time instructions.
It doesn't mean you want to repair something, you
Another
don't know how
great
to
use is in
repair.
art museums, where your smartphone
So you can
replaces
download from the
analog
website.
tours. When you point your device at each painting, an overlay of information.
It's known every Lego store.
So they go.
Walk in, grab a box off the shelf, hold it up to this flat screen that has a camera on top, and visualize the entire model animated right on top of the box. It's so successful that
OK，自己再慢慢自己看哦，因为我会讲不完。所以是 AR 东西。
Expect to see.
So you want to learn AR, you need to learn what's the camera model, what's the camera calibration. This a little bit bored. 你那个结果的后面都是技术，技术有时候有点比较无聊了哈。我觉得所以上课有时候比较无聊。好，用英文的，哎，我要教你。那 So this lecture for the calibration again, what will I teach you? I will teach you cross-form solution. Cross-form solution is AX equal to B, B equal to 0. So when you have this kind of format, AX equal to 0, okay, we will use SVD to that the A or its a covariance matrix equal to eigenvector, eigenvalue, and rotation matrix. And we find the small value close to or equal to 0 corresponding eigenvector is the answer. Cross-form solution is from A. Okay, you do SVD become 3 terms and find a small one equal to close to the 0 that eigenvalue. They are corresponding to one eigenvector. That eigenvector will be your answer. This cross-form solution. The second one, either one. If the case is AX equal to B, B not doesn't equal to 0, we will use pseudo inverse to solve the problems. B is not equal to 0. Okay. The third term, this one, is some square difference. In deep learning, we use divided by batch size, so mean square difference. Right now, in deep learning, we use gradient descent. However, deep learning, gradient descent is not the best method because it's easy to trap in the local minima. But in machine learning, they use better method. One is the LM here, LM method. The second one is the EM method. 就是说，在那个 machine learning 的时候，在解这种二次题的时候，它的方法是比 deep learning 还好。那 why deep learning doesn't use this method? Difference in machine learning, our data is not big data. Machine learning, when you solve that one, okay, usually our data is not so big because the parameters for machine learning is much less than the parameters in deep learning. So deep learning has a huge unknown parameters. So you want to solve million parameters or 10 million parameters. It's not easy to use LM or EM, so they use gradient descent. But the new paper here for the deep learning, there's a new paper. This one. this paper. In year 2018, okay, the famous Hinton 是大师哈，他们的实验室Toronto 这边哈，Google Brain 他们发表了一篇 paper， 用 EM 取代 gradient descent 来解决那些deep learning 的参数，这很复杂。那结果当然更好。This paper, they use EM method solve. 所以我意思是说，一样，我们这些人都慢慢的 they try to move. There in many methods in machine learning is better. So that we need to wait until those big guy to move to solve the problems and move this method to the deep learning to solve it. 我们比较没办法去解决这个比较复杂的问题。那我说我们是使用者，好，那我们就等他们把这边弄健全以后，你只要扣这些方群就好了。让他们用EM的方式来解决那个 deep learning 的一些问题，这个还在发展中间，它持续在发展，这个有这种 paper 了哈，在解决这个问题。好，让你知道一下，是有这种 paper 吧，缩小一点，来让你看一下就好了。结果更好，但是还不成熟。这个，这是新方法，这旧方法，新研究还是新方法。这边有点难度，所以劝你不用念。Okay, so in this Zhang's calibration, I will teach you LM. It's a nonlinear approach. You just use it because the OpenCV already write the source code of LM for you. Okay. And for the EM, okay, we can teach you, but what's the EM? There's two methods. E is expected. M is maximization likelihood. So M is likelihood. So I'll teach you likelihood. E is average. EM. So what kind of situation we will use EM? Which situation we will use LM? LM is this one. B is ground truth. B prime is the unknown. So when we have a ground truth B, we label it to B. And their B prime is AX. So we try to solve A. In this kind of situation, we can use LM. And this is an example for this paper. So this paper will use closed form solution. We'll use pseudo inverse. That's what we call initial result. And then they use LM. LM include a second order Taylor series, so they can solve the problems. Okay, but what kind of situation we will use EM? It's you don't know the B prime. You don't know the B. You don't know B double prime. You don't know B prime. It's meaning you don't have a ground truth. When you don't have a ground truth, that's meaning you try to do prediction. So when you do the prediction, you can use the EM. LM 跟 EM 的用法不是随便用。我说 LM 是你有 ground truth 的时候是可以用的，是用 LM。那这篇 paper 有。EM 的话是你没有 ground truth， 但是你可以把它逼出来。这时候就用 EM 的方式。我举个例给你，我举概念给你听啊。这个 ，So your goal is here. So how do you estimate the result? Let's go. But you don't know, actually you don't have a ground truth. You don't need to do labeling. 那怎么办？那概念是这样子，就你要去这是 predict 未来的事情。那你怎么办？就意思说我叫你 predict 说1个月后的今天星期四天气会是怎样 ？predict， 你要去预测这个东西未来的东西，没有 ground truth 啊，那你怎么办？就是这个概念。好，这概念怎么做？基本是这样子。So our goal is this red color target is our goal. So the first one is EM is being you try to do based on the sample previous the history 旧的资料，今天是30号吧，9月30，你根据旧的只要1个月后，大概10月30号，你把10月30 100年的资料收集起来，不是前后正负10天把资料收集起来 ，right? Create the previous 100 years, you collect the data. You try to find the average value. That's called expected. 平均 expected 期待值嘛。You try to find the expected data here. 所以你有个初始值。Even though you have this kind of distribution, all this kind of distribution 会发散嘛。先找它的期待值出来。Expected value 这个中心点。But however, you don't know the target. 你还是没有目标啊，你不知道 target 在哪边，可是你有期待值。那这时候怎么办？第二个是什么？第二个叫做 likelihood， 就相似度。就我们一直讲相似度 ，likelihood is like the Gaussian distribution, the exponential term. That's the likelihood. So, do the likelihood is meaning what? Probably is the approach has been the velocity， 就是你可以偏断那个速度，有没有？速度，就是说你天气变化的速度。所以第一个是可能平均值，第二个可能是判断一些一次微分东西嘛，就速度嘛。2次微分是加速度嘛。Original data is the data. The second one you want to estimate it will be based on the velocity, based on the accelerator. 速度就是天气变化的速度，天气变化的加速度这些东西。速度是什么？就我讲，就今天30号嘛，你可以前一个礼拜 ，based on the previous 7 days, you see the change for the daily change 每天的变化嘛。那这些变化就是帮你 predict the direction, the vector direction, the approach direction. So based on your current position, based on the prediction velocity, and you can keep going and approach to the center. So that's the expected value and maximal value, maximal likelihood. Now, after you predict and you do the similarity measure, to adjust the velocity or adjust the accelerator using the likelihood 相似度，因为你 predict 就有一个 target， 那用 target 来去评断那个相似度这样子。OK， 好 ，So this is EM, this one. You do iteration, keep iteration until this value doesn't change too much. For each time, you just do a little bit estimation prediction. The final one is I just told, okay. The final one is that we try to add one more constraint term. So use the Lagrange to improve the result. 这个 lecture 我上20年前就在讲这个东西，所以这边也慢慢也是一样，它慢慢会加这个东西。那这个事实上在我们讲 SVM 啊，在 machine learning 用的很广，这样子，它会减少 outlier is meaning noise, reduce the noise. OK， 好， We keep going. So we start talking about the calibration, and we move to page 24. We move to page 24. So this one is for calibration. So we start from page 24. Okay. So for the calibration, the first, this is from paper. Okay. This is on the paper. I just copy the paper out, but I reorganize the paper. So first one, you try to print out pattern. Okay, attach this pattern. But print out this pattern and attach in the this plane surface. And you take 15 to 20 images, then take this one. Move. Do the motion 20 times, 15 to 20 times. Okay. But in homework, we will take a photo for you. We will use one camera and take this photo for you 20 times or 15 times and give to you. And then you calibrate the camera you don't know, but you can calibrate about the intrinsic parameters, extrinsic parameters of the camera. And after the second step, you detect the corner points. You detect this one. Use OpenCV. Those functions we have already did on OpenCV. So it's called a function of OpenCV. So you do corner detection. And this will be your ground truth. AX equal to B. That will be your B, the ground truth. Okay. So that's it for the data collection. And step 4, 5, 6 is we try to estimate the intrinsic parameters and the extrinsic parameters. So first one is a linear approach using cross-form solution, and then using the pseudo inverse. But this doesn't mean use this different purpose. Okay, intrinsic parameter use cross-form solution, but radial distortion parameter use pseudo inverse. 这两个就我刚刚讲的，这两个不是拿来就是用两次，不是哦。是 when you have this, because the intrinsic parameter is AX equal to 0 problem, so use closed form. The distortion parameter because it's AX equal to B problem, so it's a different parameters. They use the pseudo inverse. 不是两个一起用，不是有不同参数，一个是内部参数，一个是 distortion 参数，这些我们都要去校正的。所以状况不一样，不同这两个 either one， 这两个 either one， 然后最后这两个会综合在一起用 LM 来做，好 mix to the LM。那我们后面又慢慢讲。So find this pseudo inverse. So final one we will use this one LM to solve mean square error to solve again to refine the intrinsic parameters and the distortion parameters, and we'll do refinement here. Okay, so that's the approach. So next hour I will start to talk about this one. How do you do the attenuation? Okay, we take a break. 休息一下。